All right, we're going to talk about reference angles. So a reference angle, and the symbol for a reference angle is theta. I call it theta hat, theta with a little hat on, right? And the definition of a reference angle is the acute angle formed by the terminal side of the angle and the x-axis. So it's always going to be a positive acute angle. If you look at the pictures below, you can see a reference angle in each of the four quadrants, right? In the first quadrant, we have theta in quadrant 1. And when theta is in quadrant 1, theta equals theta hat, because that is an acute angle formed by the terminal side of the angle and the axis. When we're in quadrant 2, first I want to remind you that theta goes all the way from the positive x-axis to that line, right? And you can see the little orange theta hat in there. So if I wanted to define theta in terms of theta hat, when theta is in quadrant 2, I would do 180 minus theta hat, and that would give me the measure for theta. If we were in radians, we would use pi. In quadrant 3, again, remember theta goes all the way around from that positive x-axis all the way around. And so if we wanted to define theta in terms of theta hat, it would be that theta is 180 plus theta hat. Or if we wanted to use radians, pi plus theta hat. Lastly, quadrant 4. Again, that theta goes all the way around. And if we were going to describe theta in terms of theta hat, we would say that theta is 360 minus theta hat, or 2 pi. So when we do these problems, we're going to do the first few really mathy, and then we're going to make it a little simpler. So I have 252 degrees. 252 degrees is in quadrant 3. And in quadrant 3, theta is 180 plus theta hat. So since I want to find theta hat and I have theta, I'm just going to rearrange that formula. If you wanted to go ahead and plug the theta in that previous step, you certainly could. And then I'm just going to put my information in and solve it. So theta hat is 72 degrees. What that means is that 252 degrees is 72 degrees more than 180. That's kind of how I want you to think about it. For 105, we're in quadrant 2, where theta is 180 minus theta hat. So those 4 formulas for reference angles need to be kind of in your brain. So we can move it around to solve for theta hat, plug in our information, and we get 75 degrees. So 105 degrees is 75 degrees away from 180, right? Because that 180 is the x-axis. If we have a negative number or a negative angle, we want to find its coterminal angle. So to do that, I'm going to add 360, and now I'm at 132 degrees, which is in quadrant 2, where theta is 180 minus theta. And if you don't have that in your brain and you just want to sketch it out real quick and look at it, you can do that too. It's fine. We could plug that coterminal angle, the 132, in right there for theta, or we can rearrange our formula and plug in, and 48 is our theta hat. So 132 is 48 degrees away from 180. Oh, looks like I started early here. This one's negative, so we want to find coterminal, so we're adding 360. So we get 210, which is in quadrant 3. There's my formula. Rearrange it, plug it in, and my reference angle is 30 degrees because 210 is 30 degrees away from 180. For 195, we know 195 is in quadrant 3. So that's 180 plus theta hat, rearranging, subtracting. If you can do it without doing all that, that's great. Let's just think about it. 195 is 15 degrees away from 180. For the negative 600, we want to find the coterminal. So we're going to add 360. We're still negative. We're going to do it again. Now we're at 120, which is in quadrant 2. There's our formula. Rearrange it, and we get 60. But think about it, that 120 is 60 degrees away from 180. 510, now we're going to go a little faster here and not use the formulas. So 510, it's more than 360, so we're going to take out a rotation. I get 150. So my reference angle is 30 because 150 is 30 degrees away from 180. For negative 480, we're going to add our rotation. So we're still negative. We got to add another one. We get 240. And 240 is 60 degrees away from 180, right? 60 would be that reference angle. When we have radians, we're going to do a lot of equivalences. So first, for 11 pi over 9, I need to remember that 9 pi over 9 is pi. So if we want to think about this, that's clear then that 11 pi over 9 is more than 9 pi over 9. So it's in quadrant 3. There's my formula for quadrant 3. Flip it around, plug it in, and my reference angle is 2 pi over 9. Again, it's pretty obvious that 11 pi over 9 is 2 pi over 9 more than 9 pi over 9, which is pi. All right, so 5 pi over 6. Again, we're going to think about it. We know that 6 pi over 6 is pi. We're in quadrant 2, right? And we would pull our formulas out and plug in. Or you can think about it as 5 pi over 6 is pi over 6 away from 6 pi over 6, which is pi. For my negative 7 pi over 12, I need to add 2 pi, right, to find that coterminal. So 2 pi is 24 pi over 12. When I add it, I get 17 pi over 12. So 12 pi over 12 is pi, and 6 pi over 12 is pi over 2. So 18 pi over 12 must be 3 pi over 2. So we didn't go all the way into the 4th quadrant. We're just in the 3rd quadrant. Formula for quadrant 3, flip it around, plug it in, 5 pi over 12. But I also know pretty quickly that 17 pi over 12 is 5 pi over 12 more than 12 pi over 12. For 17 pi over 15, everything looks pretty good. We know that 15 pi over 15 is pi. So we know that we must be in quadrant 3. There's my formula. Flip it around to solve for the reference angle, or plug in what you've got and solve that way. It doesn't matter. And when I plug in, I get 2 pi over 15. Again, it's pretty obvious that 17 pi over 15 is 2 pi over 15 more than 15 pi over 15. Little joke for you there. We're going to be using these radians a lot, so buckle up. When I have negative 3 pi over 5, so again, it's negative, so I need to add a rotation, right? And so 10 pi over 5 is 2 pi, and I'm going to add it, and I'm going to get 7 pi over 5. Well, I know that 5 pi over 5 is pi, right? So the reference angle must be 2 pi over 5. If you need to do the actual formula and plug it in every time, do it. But I really want you to work on kind of visualizing it and understanding what we're talking about. That we're really talking about the distance from that x-axis. So it's either going to be from 0 and 2 pi on the right, or from between how far it is from pi on the left. For 26 pi over 9, it's more than 2 pi. So we're going to take out a rotation. We're left with 8 pi over 9. And surely you'll agree with me that that is pi over 9 away from pi. Negative 16 pi over 5, that's more than 2 pi. So we're going to take out, or rather add a rotation, because it's more than negative 2 pi, right? When I add my rotation, I get a negative, so I'm going to add another one, and I get 4 pi over 5. Well, I know that 5 pi over 5 is pi, so my reference angle must be pi over 5. Last ones, I have a negative, so I'm going to add a rotation. I still get a negative. I'm going to add another rotation, and I end up with 13 pi over 12, which is pi over 12 away from the x-axis, right, which would be 12 pi over 12. 41 pi over 12 is more than 2 pi, so I'm going to take out a rotation. I'm left with 17 pi over 12. I know that pi is 12 pi over 12, so my reference angle, or theta hat, is 5 pi over 12. And the last one here, 49 pi over 15, is more than 2 pi, so I'm going to take out a rotation, and I get 19 pi over 15, which is 4 pi over 15 more than pi. I hope that makes sense. Let me know if I can help.